Consider a long, thin conducting wire carrying a uniform current I. A particle having mass m and charge q is released at a distance a from the wire with a speed v0 along the direction of current in the wire. The particle gets attracted to the wire due to magnetic force. The particle turns around when it is at a distance x from the wire. The value of x is. The question says that current is I in the wire and at a distance a, the charge is moving in this direction having speed v0. A few things we should always remember while doing a magnetic field charge motion and a magnetic field question. That is, speed never changes. Okay, and trajectory is circular. Trajectory is circular. These two things we should never forget. Now, they are saying what the distance from the wire of the charge when it takes a turn. Turn means this particle, let me tell you, as I have written circular, we can find out the motion from here if it is moving like this along the current. Where will it turn? Here or here? The question clearly says it's moving towards the wire. So the charge particle is going to move like this. And the question is saying turns around means 180-degree turn. So it started from V0, it will have to be V0. At every instant the net velocity, the net speed at any point, the final speed will always be V0 because in magnetic field speed never changes. Okay. And we can also find out using this formula Q V0 J cap cross B. It is I cross R is called Barrett-Savart law. Using Barrett-Savart law, you can find the magnetic field. Okay, dB is equals to K ideal cross R cap by R square. So ideal cross R means current cross product with position vector, which is clockwise. Clockwise means inside the plane of paper minus K cap. So I'm taking minus K cap. Q V naught B J cross K is I minus I. So that's why particle is moving towards the wire in the x direction. It is getting attracted. Now we just need to find out this displacement. We can find out this displacement using acceleration term. Q V naught B whatever let V divided by mass. See, currently I am writing simply only for this instant. As the particle is taking turn, B is changing because distance from the wire is changing. So at any instant, though speed will remain same overall, but x and y component will change. Accordance ki always you will get the speed V0, but they will change. I am only concerned with displacement in this direction, so I am only concerned with the x component of the velocity. And x component of velocity will keep changing because it is governed by magnetic field of the wire. So once I find out this at any instant the x component of acceleration, I can try to find out the displacement because I have a relation which joins acceleration with displacement, that is ax is equals to vx dvx divided by dx. As we have studied in kinematics, v dv by dx is the relation of acceleration with velocity in terms of displacement. From here only we get the derivation of third equation of motion. So let's find the random at any instant the force, and from that we can find out the acceleration. At any instant the force is q v cross b. At any instant, though speed will always be v0, but x and y component will keep changing. So vr will be vx I cap plus vy j cap. Since it is moving towards left, so negative vxn plus vy. That is vr, and br will be 2k I by r at any instant, say at a distance x r. I'll take it as x only. That is n minus k cap, always minus k cap. So now let's write force formula q minus vx I cap plus vy j cap cross product with 2k I by x minus k cap. Okay, So at any position, force will be 2kiq. That is going to be the constant part. So I cross k, this minus minus gets plus. I cross k is minus j. So Vx by x minus j, and j cross k is I, but there is a minus sign, so minus Vy by x I. That is a force function. Now we only are concerned with the x component, which is the I cap component. So acceleration will be 2kiq by mass, and this term only, which is a negative term, okay, minus Vy by x I cap. From here we can see entire thing is a constant. So I'll write this later. Let me call this constant as k. Now k I'm already taking. I'll take it as, say, s. S I'm not taking much, so I'll take the term as s minus s Vy by x and I cap. Okay, so let's see. S I'll keep later. So acceleration can be written as Vx dvx by dx is equals to s minus and Vy by x. So I can write Vx upon Vy dvx is equals to minus ka x upon x dx. Now this Vy can be removed, can be written in terms of x like this, because speed never changes. So at any instant speed will remain v naught only. It can be written as vx square plus Vy square. So I can write v naught square minus vx square as Vy square and plug in here. So we have Vx upon square root of v naught square minus Vx square dvx is equals to minus s log of x. Now log limit I'll have to keep. I've already differentiated. Here I have to differentiate, but there's a shorter part. I can integrate and keep it on the right hand side. Limit, first it was at distance a. Now when it reaches here, the x component of velocity will be v naught only, because always speed is v naught. V naught is vx square plus Vy square. At the highest point there is no Vy, so Vx will become v naught. Okay, so when I started from the velocity v naught only in the y direction, the x component was 0 because it was moving in the y direction. At that time x component of velocity was 0, and at that instant I was at a distance a from the wire. Okay, and when it has a distance when it is at a velocity v naught, because Vy will be 0 and speed has to remain v naught. So when it reaches v naught, I will be at a distance, say, x dash. So here I am writing as x dash from the wire. Now I have to integrate it and get the answer. First I'll solve this. Minus s log of x dash divided by a. That part is solved. This part needs to be solved. So I'll solve it in the next page. So I have integration vx dvx minus s log of x upon a, x dash upon a. I hope this is coming in the frame. Yes, it's coming in the frame. Yes, fine. Now how to solve this? V naught square minus Vx square can be written as t square. Says I'll take it as t square, and then minus 2Vx dvx is equals to 2t dt. 2 gets cancelled, so minus Vx dvx is equals to t dt. Let's put it here, t dt. This is going to be t only. Okay, and then here I am writing minus s log of x dash by a. Let's cancel. Now let's keep the limit. When initially Vx was 0, t will be v naught, and then finally at the highest point Vx is v naught, t will be 0. So I get 0 minus v naught is equals to minus s log of x dash by a. So minus minus gets cancelled, and we get v naught by s is equals to log of x dash by a, and x dash will be x dash by a will be e power, just a second, yes, e power v naught by s. That is how we can write. And x dash will be a e power v naught by s. That is the value for x dash. I hope everything is correct. V naught से v minus s. Okay. Log of x dash by a. Fine. I think this correct, I hope. Fine. I'll take it as x dash is equals to a e power v naught by s, and s can be later I can write it as what I have assumed s is a constant 2k iq by m, that I'll later write it here. Now we have reached the midway point, not exactly midway, somewhere here, when I was at a distance x dash. Now again the story will begin, and this time the velocity vector will be like this, where vx will be in the negative I direction only, vy will be in the negative j direction. So from this point, say if I call it p to q, now we are going from q to r. For that again we'll write the same thing. Force is equals to q minus vxi minus vyj cross product with 2kix minus k cap, same function. So we get q 2kiq by m. If I'm writing acceleration, minus and minus becomes plus, I cross k minus j. So we get vx by x minus j, I cross k minus js, and minus minus gets plus, and j cross k will be I. So vy by x I cap. This time my acceleration x will be, this term I am terming as s vy by x. Okay. Now I can write it as vx dvx by dx is equals to s vy by x. So rearranging, everything going to be same. Square root of v naught square minus vx square dvx is equals to s dx by x. Same thing we can continue. This will become integration of dt. Same thing. Everything is going to be same. Is equals to x log of x. Limit will be from now x dash to this value x. This is what they are asking, na? Capital X. So x dash to x. So while I started the second journey from q to r, the value of t from here we can keep at q. Vx is v naught, so v naught minus v naught 0, it starts from 0, and when it reaches here it has only the y component, which will be v naught. So this time I am getting v naught is equals to s log of x by x dash. Okay, this time we are not having any minus sign. Okay, so v naught divided by s is equals to log of x upon x dash, and we need to find x. So we have log of x upon x dash is equals to v naught by s. So x by x dash will be e power v naught by s. So x will be x dash e v naught by s. Now we already calculated x dash. X dash was here, a e v naught by s. So I'll write it here. It is a, x dash is a e v naught by s dot e v naught by s. So x will be a e v naught by s into 2. Okay, because this get added. Now we can write s is 2k iq by m, no? So now we write 2k as mu naught upon 2 pi. iq by m, that we have to write, and 2 also gets cancelled. No, s is in the denominator. Fine. So 2 v naught, so I'll write 1 in the denominator na, divided by mu naught upon 2 pi iq by m. So actually it will become a e power 4 v naught, 4 pi v naught, m also, because m is here, divided by mu naught iq. Let me write it properly, maybe I am writing wrong. So I'll solve this only. 2v naught into 1 upon s. 1 upon s is 2 pi m by mu naught iq. That is better. For m pi v naught divided by mu naught iq. So x will be a times of this entire thing I solved, e power 4m pi v naught upon mu naught iq. That is the answer to the question. Please remember that the basic thing in the question is you have to find the acceleration function and put it equal to v dv by dx. The question is lengthy because of its integration, nothing else. One small error I have done in the question, this minus sign I forgot to take, and because of this minus sign, one minus will remain. Okay, and this will be actually minus, so this will go here and minus will get. Okay, here there is no problem of minus. Now here also there will be a problem of minus sign, so again I'll get a minus sign. Okay, and final answer I'll get minus, and in the final answer there will be a minus sign that I missed because of this t dt. So vx dx is t dt, so I have to write minus t dt. That's a small mistake. I hope you would have also noticed while I was solving. Rest there's no issue.